Hi, this is the Moore theorem. Okay, someone asked me to explain it in detail. Okay, this is very useful theorem. Okay, to solve 2021 12A number 22. When you have a complex numbers in this polar form, especially the magnitude is 1. It doesn't matter, magnitude will be different. But especially we're going to take what magnitude is 1. So this point should be on this unit circle, right? You can choose this point, cosine zeta and sine zeta, right? In polar form, cosine zeta plus I sine zeta. Okay, this is the point P of here, P1. Okay, now we're gonna make some exponent number of here. So what happened? Suppose if n is 3, this exponent by the theorem going into the angle. You can prove this one, okay? But by a mathematical induction proof, okay? So what happened at this point? This is original point P1 over here, but this going to inside their new point is over here on the same unit circle over here. That is new point, 3 angle, right? So what happened? Angle movement, right? 3 angle moved what? To the count clockwise. This is zero, this is zero. So this point is moved over here. Okay, that is the Morpher's theorem. Okay, now what is Euler's formula? So Euler's use what different operator over here. Defined this way: cosine zeta plus I sine zeta by e to the I zeta, or someone use by e to the j zeta. Okay, this is a very good operator. Okay, so cosine zeta and sine zeta, this is the real part. Cosine zeta is the real part. Sine zeta is what imaginary part, right? But real part, when you now e to the negative zeta, that is can be expressed this way: cosine negative zeta plus I sine negative zeta. But cosine is even function. This one should be equals cosine zeta. But sine is odd function. Minus sine, move to the front. Okay, this is definition of e to the negative j zeta. But we have the real part, especially. Real part expressed what is it? Sum of this one. Conjugate. This is what conjugate pairs, okay? When you add these two conjugate pairs, imaginary part goes to 0. We have only real part, okay? That is real part. But this is twice, that's why we divided by 2, okay? It's just simply, we use a different operation. Instead of this one, we can use what W1. This one is what W minus 1, that is conjugate of this W. Or this one also what W1 plus W negative 1 over 2. That is real part. This is imaginary part. W1 minus W negative 1 is conjugate and divided by 2i. Okay, this is Euler's formula. Okay, now take a look at this one. If we have right W to the 7 equals 1, so we're going to extend it, the root is what to the complex, imaginary. But there will be what? 7 root, okay? That is degree 7. Okay, the magnitude is 1, all roots should be on this one, unit circle, we know that. So 7 root, already we start from here, because what W7 equals 1, right? 7 root is 360 divided by 7, right? That is 2 pi over 7, isn't it? That is 2 pi over 7. That is 1 over root over here. W1. This second one, third one, every root what they have the difference same angle, right? This is what holding. This is 4 pi over 7. This is 6 pi over 7, right? Something right there. Keep going. So there was 7 root on this unit circles. Okay. But we consider over here the real part, cosine 2 pi over 7. This one is what it is. W1 plus its conjugate and divided by 2. That's the first angle set, okay? But you know that W1 and W6, they are conjugate pairs because the real is the same number up to here. This is positive imaginary plus imaginary BI. This is what? Negative BI, right? So A plus BI, A minus BI, they are conjugate. Okay, what about cosine 4 pi over 2? This is W2, okay, and the conjugate term, and plus divided by 2. Okay, and cosine 6 pi over 7 equals W3 plus W minus 3 over 2, that's it. But this is conjugate root. Okay, W negative 1 equals what? W6. Okay, conjugate over 2, W negative 2 is actually equal to W5. Okay, W5. W negative 3, W4. That's it. Okay. So they can move on this point. Okay. This is the root of what? The equations here. There's a properties over here. When you add all these roots, okay, W1, 2, the last W7, always equals to 0. Maybe you can prove this one too. Okay, maybe you can search on internet. Okay, it's simple. The next one, the last one already what? W to the 7. When you make a 7 over here, that is already 1, right? Because we start from this point. Up to here, that is negative 1. Because this last one is 1. Okay? The next one is conjugate already, right? You guys know this already. And also, this is operation of what? Euler's vectors. W2 times W3 equals W5. Because you have a 2 cell over here, that means 2 cell. And 3 cell will be 5 cell. Okay? They move right up to this 5 cell. That's the operation of Euler's formula. Okay, now back to work the question over here. This is number 22. Suppose that root of polynomial are cosine 2 pi over 7. 4 pi over 7, they are different, same difference. And 6 pi. Okay, that is what arithmetic. So 2 pi divided by 7, there will be about 7 root. We can use that root of what? Euler's formula. 360, 2 pi divided by 7. We have what? 7 root over here, okay? Because each one is a conjugate. This is the one of the root. This is one of root. This is one of root. Okay? But actually, cosine 2 pi is sum of this root. So we take care of every root over here. Okay, that's why this is possible, okay, can be solved using Euler's formula. All right, this is number 22. So we have a polynomial equations, and its root cosine 2 pi over 7, cosine 4 pi over 7, and cosine 6 pi over 7. So actually, 2 pi over 7 is what? There was 7 root, okay, because 2 pi, this is the number of root, okay, right. Now take it out. Cosine 2 pi over 7 can be expressed as W1 plus W negative 1 over 2. It's conjugate. 4 pi over 7, that was W2, right? Times 2 is what? 4 pi. So that is W2 plus W negative 2 over 2. And cosine 6 pi over 7 equals W3 plus W negative 3 over 2. You can express, right, each root using what? Euler's formula. Okay? Now let's find the ABC. Okay, A is what? Sum of root. Sum of root is what? Negative A. Product of root, all three products, negative C. Now sum of right, two product is product. Okay, that is what? B over 1 is B, isn't it? Okay, using Euler's formula, you can find the ABC. Okay, this is very useful. Okay, if, for example, if suppose what? This angle is what? 2 pi over 9, that is 9 root. This is only 6. Okay, to many root, we cannot use the Euler's formula. Okay, all right. Now, go to next page to find sum of the root. I write down already. Okay, I did already. So sum of root is what? This is first root, second root, third root. How much is that? This is conjugate. That is equals to what? W6. This is conjugate W1, 5, fifth root. This is 3, W4, right? Now you can say W1 plus W2, W3, W4, W5, W6. That is all negative 1, isn't it? Okay, if you have a W7 or W0, that is equals to 0, okay? Because this is already 1, it should be negative 1. Okay, so this is negative 1 over 2. That's why A equals 1 over 2. Now the product of 3 root. This is the product of 3 root. Maybe we can work together very quickly. Okay, 2 times 2 times 2 is 1 over 8. 1 over 8 move out. I got the right answer already. Okay, now use this one. W1 times W2 is W3. W1 times minus 2 is what? W minus 1 is conjugate. W1 times 2 is what? W1. W negative 1, negative 3 is W negative 3. That's it. Okay. Now after this, we multiply W3 and W minus 3 again. Okay. Now try this one from this one. W3, W3, W6. W3 negative 1, W2. The next one keep going, okay, with this one. The next one is W4 and the next one W0. Okay. Now plus with these numbers. W0 again, W negative 4, W negative 2, and W negative 6. Okay. Alright, now take a look. What is conjugate? This is conjugate of W4. This one should be equal to what? W3, right? This one also equal to W5. This one, W1. Alright? Okay. Now take a look. W1 plus, W2 plus, W3, W4, W5, W6. This is W7, same thing. They all goes to 0. We still have a 1 over here, okay? That's why 1 over 8 times 1 is what? 1 over 8. So C equals what? Negative 1 over 8. That's fine. Now take a look here. Sum of y each two product. This one, okay? R1 times R2, R2 times R3, and R3 times R1. That is equals to B. Okay? So, denominator, 2 times 2 is 4. 1 point is out. you can continue to work. W1, W2, W1, W2, right? When you multiply over here, this is the first one over here. This is the second one. This is the third one over here. We have a W1 and W1. That is a 2, W1. This is W2. This is also a W2, right? Conjugate of W5 equals W2. Okay? This is 2W2. Don't write that. This is W2. 2W2. This is W3. And this is also W3, right? Conjugate W3. So we have a 2W3. This is W4. This is also W4, right? Because conjugate of 3 equals W4. We have another 2W4. This is W5. This is also W5, okay? This is W5, conjugate 2W5. And this is a W6, W6, 2W6. It's okay, you know that, right? 2 is out. All the way inside is what? W1 plus W2 plus W5 up to W6. That's still negative 1, isn't it? That is negative 2. Okay? So, 1 fourth times negative 2 still negative 1/2. Okay? So, the value of B equals still negative 1/2. So, A times B times C. A times B times C. A we already got negative 1/2. B is 1/2. C is negative 1/8. Okay, so that's why the answer is 1/32. Okay, I hope you understand this one. Okay, all right, thank you.